Okay, so welcome to today's session. It's going to be a lab content we are going to discuss today. Just let me open my screen. Hope it's visible. Okay, so in the previous labs we have created this first experiment, right? Okay, so maybe you can rename it as experiment number 1. Okay, and then Gaussian solution or implantation. Okay, say it as experiment number 1, Gaussian solution. Now you just copy paste it to make some variation to this. Okay, so we're going to learn a few more steps today. Okay. So here what we're going to do in today's experiments, we're going to make a deeper implantation today. That's your experiment number 2. So just rename it as deeper implantation. Okay. Now so you will know where to change the command, right? So to see the output, you have to go to the node. To change the input, you have to go to the tool. So right click on the tool, 8 input commands. Here, I hope you all remember this line command and the region command and the init command. We already covered the past video, right? The past lectures. Now we're going to learn something more about it. These commands today. Okay. So this one is to select the transport model. Right now, to keep things simple, you can make it constant. What is constant means? You can go to the help manual. I already done this, so you get this window. You double click here, so you get the process manual. The process manual, if you expand the chapter 4, transport model, constant efficient model, you can see this equation. Hope you all able to recognize this equation which we already discussed in the theory classes. Okay, something about your fixed law. So the charged memory or other diffusion models are advanced version of this. This is a very simple diffusion model that explains how the dopants get distributed while heating. Okay, so we'll be using this model for the today's experiment. Okay, so to enable it, just you have to select very simple, make this as constant. That's a change number 1. Okay, next we're going to see how to create variables. Okay, that's also very important because today's agenda, I told you, we're going to have a deeper implantation to mimic the boundary condition that we have studied in the theory classes. Now, what is the boundary condition we studied? We're going to have a deeper implant of a dose, right, in between the wafer. Okay, so for that, we're going to have a deeper implantation. For that, we're going to create a variables. Okay, so to create variables, it's universal across the CentOS tools. It could be S process, it could be S device. To create variables, you have to do this. Okay, so what you have to do is, suppose we are going to make a variable for the energy, just make this as whatever you're going to make the variable, it should be within at and at the at symbol. Okay, it should be within the at symbol. You can give any variable like E or maybe more meaningful to be as energy. So let me call it as energy within the at symbol. This is how you have to create the variable. The variable definition can be given in SWV. So whenever you have between the at symbol, the synopsis, the CentOS interpreter understands a variable and it picks the value from the CentOS workbench. Okay, so we have created a variable and I have to define it in the workbench. So how to do that? You have to click on the in between the node and the tool. You have to click here in between the tool and the node. I repeat. Then you right click. Sorry. And then add parameter. First click and then add parameter. So I'm going to call. So we have defined the variable. It's a case sensitive. So use the same name as it is you have defined in the command file. And energy, it was by default 15. That's what we did previously. And give OK. Now I want to try a deeper implant because already you know this. So you're going to try a deeper implant. So what you can do, you can right click, add new experiment. You can give higher energies. So that's your experiment. So you have to try different energy levels. You can try 50, you can try 100. Okay, just give okay. So like this you can use. So that's your today's task. So what you have to do, I mean part of today's task, you have to give different energies and try to ensure the implant is happening in the middle of the wafer. Okay, that's your task. So I'm just giving you how to do that. I just showed you how to do that. One more thing, you can also save the pre-deposition step. So far we have done, we didn't do that. So you know, because you remember, doping has two steps. One is the pre-deposition, other is the annealing, right? So here we have just saved the only the final structure. Okay, we can also save after the implant step as well. So how to do that? So to do that, in TCAD we can to do that we have to use this save step. Okay, you have to use the save step, copy it and paste it here. Okay, and then maybe not required, those things are not required for this one, and it's going to be pre-deposition, right? Give a reasonable name. You have to give underscore. So you can also see here node is also a variable. It's a built-in variable. Energy is a user-defined variable, so that's why it is between at. What the node says, node is nothing but the number being displayed here. This is first node, this is 43rd node, it is 42 node. If you want a sequential numbering of the nodes, what you have to do, right click on your project, you go to the project, then do cleanup, then you write renumber the tree. If you take this and you give cleanup, they automatically number properly. We'll see that. See, it's 1 2 3. So you can renumber it completely. Okay, that's better. Okay, now let us come back. So what I want to say is this is also a variable that whatever the number in the here, suppose you are going to run this, the file will be like n2. Understand? We will see that. Okay. So that this node number will get stored here. Okay. Then I'm going to give a reasonable name because the pre-dep step, so I'm calling it as pre-dep. And what is the once you're done, you will not able to see the 2D version. Okay, but if the new version of the TCAD, you can see them. The old version, you're not able to see them. And also, CentOS does not save the concentration information without the diffuse command. So you need to use the diffuse command, but we don't want the diffusion to happen. We don't want the heating to happen. So how to do that? The very simple idea is make it 0 second. Okay, just no diffusion happens. Okay, make it 0 second, and I will also yeah, this should work. Okay, let's save it and run it. Let me run for 15 and for different energy, maybe for 100. That's your task. You have to try and you have to find the energy so that the implant happens deeper the wafer. Okay, not in the surface level. 15 is the surface. The implant happens in the surface. Hope you remember, right? We have two solutions we have discussed: Gaussian near the surface, Gaussian what in the infinite medium. That's from the plumber book, right? So once it's run, you're able to see them. It's running. Okay, so so for this video, I'm just going to we learned how to create variables and we learn how to